What's up guys, Shawnthebro here, and in today's episode of the fighting game tutorial series we are going to be continuing improving our camera. So this time we're going to do the conversion from blueprint to code. And so essentially at the end of this episode our camera will be in code, which will make it more efficient and give us the ability to edit it from other places more easily. But it will have all the same logic that it does in the current episode. It will have tag team support just like it does, as well as solo support. If you guys are interested in getting caught up in the series before watching this episode so you can see how we've done everything from our hitboxes, projectiles, character states, all this fun stuff, then I'll go ahead and link you to the playlist right here in the top right corner. That's every episode of the fighting game series, and we are on episode 255, so we're pretty far along, but we still have a lot to go. If you guys are just interested in camera behavior, I'll link you to the first episode of cameras right here so you can see how we got to the point that we have it at this current moment. But with that out of the way, we can go ahead and get started. So this is a code and blueprint tutorial series. Of course, today we're going to be converting things from blueprint into the code, so we're going to be working mainly in the code. Now first things first, we need to create a code class. This is the part that I've already done. Most of this episode is going to be live, but I already did this part because sometimes when you create a code class, it makes you restart the engine, or you have to reload your project files. So I'm going to show you how to do that. So here I am in my content browser. I'm going to go to the section that says C++ classes and go into my fighter template folder that I have here. At this point, I'm going to right click and select new C++ class. This will work in Unreal Engine 4 and Unreal Engine 5. And then at this point, we want to find the camera class. I'm going to go to all classes and just simply type camera. You have a lot of options here, as you can see. We want to match the camera class that we have in our camera blueprint. Now, I know that we were using camera actor, so I can search for camera actor and select this one here. Hit next. Give it my name. I called it base camera. Base camera. And you can see I've already created this, but otherwise I'd be able to go ahead and select create class right here, and we would be good to go. So do that. Let the editor relaunch. Hopefully it just works. You don't have to do all that, but just get to a point where that class has been created, and then go back to your content, and let's go to our blueprint camera. That way we have something to reference when converting it to code. For mine, it's in blueprints, functional blueprints, cameras, and it's the base camera BP. So I open this up, and I can go to my class settings just to verify, but we can see that the parent class is camera actor, which is what we selected for the code class, which is good. Now at this point we want to go to our event graph. We're not going to get to converting everything to the code today for the camera because there is a lot in this class. We have to be careful and make sure we do everything exactly the same way it is in Blueprint but in code. That way we don't mess up any logic or lose anything, any features that we've implemented. So for today's episode, let's focus on one thing, which is event tick. This is the biggest of the logic. If we're able to get this done, we can do the others a lot more simply. Even though some of them are similar in size, like use camera, their logic isn't as complex as the tick logic. First things first, let's go to our code class. So if we go to Visual Studio, I have my basecamera.cpp and basecamera.h. Open up both of those. They should look like this. They're empty right now. Let's go ahead and set up a tick function in our camera actor code. Let's go ahead and copy over all the variables that we can from the blueprint into the code, and then also make our tick function, and then we'll go over actually moving the logic over. We have a boolean has set camera bounds. So starting off, let's put this in the public view for now. So we're going to do bool has set camera bounds. We'll comment it, have the camera boundaries been created and assigned locations. If we want, go ahead and make these uProperty edit anywhere, blueprint read write. Next we have left max, right max. We also have front max and back max for the 3D fighter episodes as well. So let's go ahead and add all these. I like to keep my variables from most complex to least complex in general. So we'll have that boolean at the bottom here. Let's say the leftmost point of the stage. And this is a float value. So we'll keep all these as U property of edit anywhere blueprint rewrite. And we'll say float left max. And I'm going to copy this because the next three are going to be very similar. So we're going to say the rightmost point of the stage. This is going to be right max. Paste it. This is going to be the backmost point of the stage. Back max. We'll add a comment to this one. For three-dimensional fighters. Be good enough for now. And let's add another one like this for the front max as well. Say the frontmost point of the stage for three-dimensional fighters. And it looks like I had these reversed in that order, so I'm going to make sure I keep everything the same. There we go. We also had a current field of view and a camera height minimum. So let's make those as well. Put those after the boundaries. So we'll say the current field of view. And U property is the same. I'll say float current field of view. And lastly, the maximum height the camera can reach. Float max camera height. There we go. Our variables have been transferred over. Now let's go ahead and make our tick function as well. So this is a child of a camera actor, which is a child of an actor. Actors have the ability to tick. Virtual void tick float delta time override. So we're overriding the tick function. That way we can handle it in our code class just the way we want it. We should also have a constructor for this camera. We didn't actually have that in the camera, or at least it doesn't really look like we do. Technically it's got some extra stuff to set it up when it's in a blueprint, but we should add it here as well. A base camera. So there we go. That should be pretty much everything we need for today's episode. If we go to the base camera CPP, we can start filling this out. So first things first is the constructor. A base camera, a base camera. In here we can set all the default values for our variables. And we'll just go down the list. So we have our left max equals. Now, if we have values in here assigned by default, we should set them. We are calculating it based on where our characters spawn, and so we don't have default values for any of these variables. So we can just assign them all to 0 and false. But I am going to do that here, just to be completely sure. So we have left max, right max, front max, back max, current field of view, max camera height, has set camera bounds equals false. So there we go, constructor set up. Now we want to set up our tick function. So void a base camera tick float delta time. And first thing we're going to do in here is call super tick. So call the parents tick. And then we can start filling out our own logic based on what's in the tick function in here. So in use camera, which is essentially begin play, we were getting the game mode BP and setting a reference to it. This doesn't actually have to be the game mode blueprint. It can be the regular code game mode. We can double check this, but I'm positive of this. See, we're setting the reference here. We're checking it here, but just to grab the active characters. Nothing that is specific to the blueprint. And same here, we're checking our characters. Checking the characters. 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 And characters. So nothing in here says that it has to be the Blueprint version, which means we can actually do this in the camera class. And if we are going to do that, I'll add one more function in here, which is begin play, virtual void, begin play, override. So we can go ahead and add this one, a base camera, begin play. And this one's very simple. We're going to call super begin play, but we don't need to set a reference to it unless we want to. So in the Blueprint, I like to set references so it's easier because the nodes and the lines can be a little bit difficult when there's so many of them. In here, I don't need to set a reference to it. I feel comfortable leaving it like this. I want to keep begin play. That'll come into play later. Let's keep it empty for now. We'll just check for game mode in tick. So first thing that we do in tick is check if the game mode is valid. So if auto game mode ref equals get world get auth game mode. So if we go into this if statement, we know that the game mode is valid, and we can use this game mode ref here as our fighter template game mode as long as we cast it properly. And actually, let's call this base game mode. And so now we just have to make sure we can cast it to our proper type. So cast a fighter template game mode. And we're going to cast the game mode result from get auth game mode. To do this, we will have to include the fighter template game mode. So pound include fighter template game mode.h. So now if this succeeds, we'll know that our base game mode is a valid variable, meaning that our game mode is valid. So that's that first check done there. Then we want to check and make sure active team 1 character and active team 2 character are valid, or basically whatever character is currently being controlled by the players, they should both be valid. We can check them both here in one statement. So if base game mode active team 1 character and base game mode active team 2 character. These both have to be valid for our camera logic, so even if one's valid and not the other, we don't want to do anything. Again, I mentioned this in the previous episode, that may change. We may have a solo mode where only one character is valid or being played, kind of like beat 'em up style, but we'll handle that at a different point. Right now we assume both characters have to be valid. So that's both of these statements here. The next thing we do is get the actor location for the active team 1 and active team 2 characters. So base game mode active team 1 character. Get actor location. This will get the current location of this actor. And we want to do the same thing for team 2 character. So what we're really doing here is we're trying to get the average distance for the Y and the Z axes. The X axis is the depth, and we handle that separately in the 3D episodes of the fighter. So you see I'm not doing it here. So in this case, I want to get actor location dot Y. And I want to add this line. So add the two actor locations together. Dot Y. Just like this. And we can set this to a variable float. Sum Y equals. Then we want to get the sum of Z. So we're going to do the same line here, but instead of adding the Y's together, we're going to add the Z's together. Okay, so that is this part right here. Now we also divide them by 2 to get the average. We use those averages to set the camera height minimum and also to actually move the camera. This is going to be very, very important because we're going to set the camera's location to certain spots based on these averages. One thing to note, I'm realizing I called this camera height maximum. That is incorrect. Let's rename that. I apologize. This is min camera height. The minimum camera height. Sorry about that. Make sure you change it everywhere. And we will continue on. Okay, so going forward now, as I said, we have to divide these sums by 2 to get the average, and then we're going to set the camera height minimum equal to the average of z. So float average y equals sum y times 0.5f, or divided by 2. Then we have float average z equals sum z times 0.5f, or divided by 2. Now, it's not required that you separate these lines like this. I'm just trying to do it logically so it's easy to convert, but also so that we can understand what's going on while we're doing it. So these are the first nodes here. Next thing we have to do is check if our camera bounds have been set. So we want to go below this and check if has set camera bounds. If we have, we're going to do 2 less nodes than if we haven't. If we have, we're going to go here. But if we haven't, we're going to do these nodes here. Let's do these first. That way we're kind of reading it logically as we're going through the blueprint here. So if we haven't, that's going to be an else statement. And in the else, we were setting the camera height minimum to the average z value. So min camera height equals average z. Then we were setting has set camera bounds to be true since we've now done this. So has set camera bounds equals true. Now, if we have already set the camera bounds when we come into this tick function, we want to do this instead. You'll notice that whether we've set the camera bounds or not, they meet up here, so we don't need anything in this if statement. So let me fix this by actually checking if has not set camera bounds and just doing these 2 lines in here. That will make it even simpler. So basically, if we haven't set the camera bounds, set the min camera height, and then say we have set the camera bounds. There's actually something else that I haven't done here. So if we go back into the blueprint, you'll see there is this section up here, which is getting the actor's location X value and determining manually by a hard-coded value how far away the camera should be from the characters. So you'll see it's going off of actor team 1 characters since they should be on the same X for 2D and 2.5D fighters, not the 3D fighter. That will be a special case that we will edit in those episodes. But for our current case, we're just getting the actor location of character 1, breaking the vector, grabbing the X value, manually subtracting 550. We can do that up here as well, although I would actually prefer to have a variable for this. So I'm going to go to basecamera.h and I'm going to make a new float here. The x-axis offset from the characters. Copy that U property and float. Let's call this offset x-axis. And I'll put in parentheses here distance. X distance from characters. So we have offset x-axis now. So if I go ahead, set this down here, offset x-axis, we're going to set that to the 550 that we were hard coding before. So now we need to get our X location. So I'm going to make another variable here, float. Call this camera X because this is where we want the camera to be on the X-axis. And we're going to set it equal to base game mode active team 1 character dot get actor location dot X minus offset X-axis. And yep. Use the arrow operator instead of the period operator. And there we go. So now we've done this as well. And I'll even include the comment. Determine how close the camera is to the characters. And I'll comment this out. If it helps, determine the sum of the y-axis determine the sum of the y-axis locations of the characters. So y-axis and z-axis locations of the characters. Determine the average location, y-axis and z-axis locations of the characters. We'll go in here, set the minimum camera height to the average z-axis location of the characters. Alright, looking good. Now, we've done everything up to this point, minus these two nodes. These are for the next part. So the next thing we want to do is determine if the camera should actually move to the spot we determined in these average values by checking to see if it's within the bounds of the left max and the right max. We have this in a function called determine if camera should move. So we can make that base camera.h bool determine if camera should move. It's going to take in a float new camera y location, because the z value of the location doesn't have a maximum for the camera, right? We set a minimum for the camera, but we're going to clamp that value. So we're just checking y values here. And you could clamp these values as well. You don't have to have a separate function for this, but this is how I did it at the time, and I'm just translating it to the code. So we'll make this a U function if we want to use it in the camera BP, so blueprint callable. And let's add a comment. Determine if the camera should be able to move to the calculated location on the y-axis. Now we can create this function. So I'm actually going to put it above tick. I like to have tick as the bottom, that way it's easy to find it. So we do bool determine if camera should move. Make sure you scope it, a base camera, and it's taking in float new camera y location. Now we can go into this function. So basically it checks if the location is greater than left max. If it's not, return false. If it is, check if it's less than right max. If it's not, return false. Otherwise, it's within the bounds that we want, so we can go ahead and return true. So this is pretty simple. We're going to check if new camera y location is greater than left max and new camera y location is less than right max, return true. And then otherwise we're going to return false. So if the camera is within expected range. If it is, it will return true and it will never hit this return false. If it doesn't go into this if statement, it will skip it and it will return false. So we want to call that at the bottom of our tick function here, determine if camera should move. And we want to pass in our average y that we set up. And you can see that from here, camera move location coming in from the average of the y. Then the result is being captured. To do this part of it, we can just put this in an if statement. If so if it's true, we set the location here. If it's not, we set the location here. So if it's true, we're setting the location to the new location, which is a vector that we're creating from the x value we calculated and the average of the y value we calculated. The z value is the z value we calculated but clamped to a specific value. I just gave it a random value of 100,000, so we can go ahead and keep that if we want. So let's make a max camera height for this. So it turns out we want that minimum and maximum camera height anyway. Let's go ahead and add it. the maximum height of the camera, maximum height the camera can reach, and then max camera height. And let's go into base camera CPP and set this max camera height. And we can set it to that 100,000 for now if we want. We don't really need it to be nearly that high, but I'll keep it for now. What we have to do next is make a vector. So F vector, and we're going to call this calculated location. This is where the camera is calculated to go. And we're going to set it equal to F vector and fill it out here. So we want to use camera X that we calculated earlier. We want to use average Y. And we want to use a clamped value of average of Z. So it's fmath : clamp. And for the parameters, we need to pass in the value, which is average Z, and the minimum and maximum, which is going to be our minimum, or min, camera height, whoops, and max camera height. And so what we're doing is we're calling set actor location on the camera and passing in this new location that we created as the location to set it to. Sweep and teleport or false. So now we can call set actor location and pass in calculated location. We don't have to set the other parameters. By default, they are false if you look at the function definition, so we can ignore it for now. Else, if we determine that the camera shouldn't move, what we were doing was just setting the actor location to the current location, X, Y, and clamped value of Z. Honestly, this isn't really necessary. We could just skip this step altogether because we're just setting it to the values that's already assigned. We could set it and clamp the Z value like we were doing, just to be on the safe side in case it was adjusting. And so we'll go ahead and do it just to show you what that would look like, but it's really not required. So otherwise, we're going to say we can make calculated location again. This time, though, it's just going to be get actor location dot x, get actor location dot y, and it's going to be our clamp. So fmath clamp average Z min camera height max camera height. Set actor location, calculated location. Now going back into the if statement, we do a few extra nodes that we don't do if the if statement were to return false. We determine who's the left player and then set the inner boundaries based off of that. Now, set inner boundaries is one of the functions I'm not going to change today, like I mentioned earlier, because it deals with the boundaries which aren't code classes, and that just complicates things further. But we can go ahead and write determine left player if we want. So if we go into determine left player, it just checks the game mode to get the active Team 1 and Team 2 characters. Assuming they're all valid, it compares the location. And if Team 1 character is greater than Team 2 character, that means player 1 is on the right, so it returns false, that player 1 is on the left. And otherwise, if active Team 2 character is greater than active Team 1 character, then it returns true that player 1 is on the left. We can convert this to a function if we want in the code. Determine if the active Team 1 character is on the left side. U function, blueprint callable, bool is Team 1 character on left. Now we can fill this function out. Bool a base camera is Team 1 character on left. Now we're going to check and see if our game mode and our characters are valid, just like we did in Tick, so I'm copying that. I know in this instance it's being called from Tick, so if it's valid in Tick, it will be valid here. But just in case we want to use this function elsewhere, that may not be the case, so let's make sure we check this. Is our game mode valid? Are our characters valid? When they are, we can check and see if base game mode active team1 character dot get actor location dot y is greater than base game mode active team2 character dot get actor location. Both of these should be arrows. Let's fix that real quick. So if it is greater, then we return false, because player 1 is greater than player 2, which means it's to the right, so it's not on the left. We return false. Otherwise, we're going to return true. So pretty simple stuff there. And now we can go back into our if statement here, and we can check for this. So we have the function here now. We don't need to do anything with it in the code today, because the only place that's being used right now is to call set inner boundaries, which again, I'm not going to adjust today, so just be aware of that. But now we have that function ready. So now everything that we're covering in today's episode that's highlighted here has been done. We just have this last section we need to fill out. So first thing we're doing here is getting the actor locations again. We already have the actor locations in the code, so we don't need to actually get them again. And we're doing that to grab the y values, subtract them from each other, so we're finding the distance between them, and then we're multiplying by an arbitrary value and taking the absolute value, then clamping that value to determine the current field of view. So the reason it's set up like this is because after I took the difference, I found out I didn't like the way the camera looked, so I added a modifier, and then took the absolute value because I didn't want it to be negative. And even with this modifier, I found that it had a range that was too great. It could go too low and too high, so I clamped it to get the total field of view. So we're going to copy this here. So what we're going to do now is adjust the field of view of the camera. We're getting our actor locations again, so I'm going to copy these lines here, specifically the y-axis, because that's what we're using in the blueprint. That's what we care about for field of view. But we're not adding them together, we're subtracting them. So this is going to be the float dist y, or the distance y. That's what subtracting them gets. So we're going to take our current field of view and set it equal to dist y multiplied by, this is going to be an arbitrary number. We're going to replace this with a variable, but 0.12. So let's make a value for this. Let's call this float field of view modifier, and we'll make it the same u property modifier for the distance between the y-axis of the characters. So the modifier on the distance between the y-axis of the characters for the field of view. There we go. So then we come up here, set that field of view modifier, and we'll keep it the same as it is, because I picked that value because I liked it. 0.12 f, and then we're going to change this out, distance y times field of view modifier. Now we have all this. We need to get the absolute value of this result. So we can wrap this in parentheses, do fmath abs for absolute value. And we can put this all together if we want. So that's fmath abs. And then we need to clamp it between 45 and 85. So if you want, go ahead and do fmath clamp. And you're going to put this whole thing as the first parameter. And you're going to clamp it between the minimum and maximum values. So for me, I want to make two new values for this. Minimum field of view, maximum field of view. The minimum field of view, float min field of view, maximum field of view, max field of view. We're going to go into the constructor. Min field of view equals 45. Max field of view equals 85. And I'm getting these from the values we chose earlier in the series. Then I'm going to put them in my clamp in this order. Min field of view, followed by max field of view. Now we have our field of view that we want to use. At this point, we just have to set the field of view on the camera component. I had actually gone through the process of creating a camera component, which was silly because I didn't need to. Camera actor has one by default. So in the parent class, we have one. So we can still do this in the code instead of the blueprint. We do get camera component, which already exists, and then we can call set field of view on it and pass in current field of view. And if you want, you can add a null check. Probably should add a null check, but as you can see, we weren't doing it in the blueprint, so there you go. And I'm not going to go over replacing the camera today because that was a lot, but that should be pretty much everything set up. We should play, and we just don't want to get any errors. We want to make sure we can launch the editor. We'll do the rest of the camera conversion at a later point. Anyway, guys, thank you so much for watching. I hope this video helped you convert your camera from blueprint to code, and I hope you learned about converting projects and files from blueprints to code along the way. If you did, please subscribe. It benefits the channel greatly, and I really appreciate it. I want to give a huge shout out to my YouTube membership, Patreon, and Discord subscribers. You guys rock, and I appreciate you so much. Thank you for enjoying the series with me. If you ran into any problems converting your blueprint and creating a code class for your camera, feel free to join the Discord community. That support in there is completely free. I'd be happy to help you and get any issues you had fixed. Thank you guys so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.